Today I'm going to discuss about the machine learning capstone project in machine learning Azure engineer. So in the final project, so the expectation is to work on an individual data set from the scratch, where I'll be using leveraging the hyperdrive and AutoML features which are available in Azure ML to build the best model, and also to compare the performances of the model and deploy the best model and do a quick a quick check test endpoint check with the data which has been sent to the endpoint, right? So in order to do this project, what data set which the data set which I've taken is the kind of it's the data which I'm working in my project professionally. So I have taken a data wherein which it is uh, uh, like it has basically it's a classification model. The model is supposed to predict whether corresponding a park or a pub outlet is gonna bankrupt or not. The reason why this model is gonna helpful for the businesses, if you're anticipating, if you're able to proactively or predict which are the parks which are gonna bankrupt, this will eventually help to mitigate the risk exposure for the manufacturer. So manufacturer will be, in this case, the manufacturer will be selling some beverages to the customers, and when selling it in order to make the transaction faster, they'll be selling in terms of the credit. So what happens if you're able to bankrupt? I mean, if a customer goes bankrupt, we'll be able to predict well in advance so that the whatever the credit which we give it to the corresponding customer or to a park will be can be reduced, or it can be reduced, or it can be avoided just in case. So by this way, and also considering the COVID effect, there are a lot of parks which are going, or pub outlets which are going bankrupt. So this model is really essential for the manufacturer to be in place so that they can understand, they can foresee what is coming up in the market, right? Having said that, let's go deep into the requirement of this project, where we first initially started with hyperparameter tuning. So this is, and in this project I used my own Azure subscription. In this project, like you see, as you see, I started with an experiment name of hyper tuning. Then I created a demo cluster. Moving on, then we wrote a script configuration wherein I'm calling the function train model.py. In this function, on the train dot model py, this is a function where it is loading the data set which has been used in the model, and I am also creating the, yeah, so this is, I'm loading the data set which I've been using the model, and also there is a like a hot encoding which is happening to convert the categorical variables into dummy variables, right? So moving on, then I'm cleaning the data. Then I'm splitting the training and rating and dropping the columns which are not required for the modeling. This is the payer ID and the month on which it has gone bankrupt. And I'm using a random forest classification here. So the arguments which I'm using, which are the estimators maximum depth, has been passed from the hyperparameter tuning. So initially, when I do a script run for one of the features which you see here, the model is complete. So once the model is complete, then we go to the a hyperparameter tuning, wherein which I'm tuning with three other features, which is estimators, depth, and features. So with hyperparameter tuning, I have the best model which has an accuracy of 0.25. So yeah, so if you see here, this is the best model which has an accuracy of 0.25. Let's now move on to the automated ML. In the automated ML, I have created the model. And one other most important which I want to call out here is, in terms of when I'm trying to print the accuracy, I'm trying to optimize uh, in terms of the recall score. So this is the reason why this is important. Is in my case, the false negatives are more important than the false positives. So in terms of, even in if you see in the hyperdrive configuration, I have given the primary metric name as accuracy. The same accuracy, the recall accuracy, has been used to fine tune the model here in hyperparameter tuning. Okay, so that's so as per the the negative accuracy, the accuracy I have is 0.25. So moving into the AutoML, the same approach, I am taking the same data set has been loaded, train and split, and so when setting up the AutoML configuration, if you see here, primary metric I have given as a norm macro recall, because I want to focus on false negative. So this is the function which basically like which has a better false negatives, and like uh, thing. So I am forcing this normal factor in my AutoML function. And moving on, I have the AutoML config where I give all the other data which are required for us to run the AutoML. And if you see here, so there have been multiple models that run, and the best model has an accuracy of 0.70, which is way better than the hyper tuning model, which was there in 0.25. So for deployment, I am using the AutoML model, the best model which is coming from AutoML, which will be deployed. So let's quickly check. Yeah, so this is the I'm downloading the best model and the PKL file of the best model, and also this. In terms of preparing the deployment, I'll be first writing an entry script, and before that I'll be creating an I'll be writing a file for auto score. So I'll be just using the AutoML model with the file which we downloaded. Then I'll be writing the inference configuration. Then I'd be doing deployment configuration. Then I'll be deploying this bankrupt model called auto v1. So if you go to the endpoint v1, this model has been deployed, and if you go to the status, see the deployment state is healthy, and the application insights are also is enabled. So once the model is deployed, I'll be just running a dummy data, and this is the authentication key which is used to interact with the model. Used to authenticate the model for to get in the to get a post or get the reply from the model. And moving on, the most important thing is the which is the sample request which has been sent to the response, which is using this specific data. Two data points have been sent. One data point is basically using the like considering this features which are really important. Based on the we went to the experiment data, we understood, okay, these are the features which are driving the bankruptcy. So one data point which is given with the data which tends to give more bankruptcy, which tends to go towards bankruptcy, and the other data point which is tends to go opposite from the bankruptcy. Based on the data which we give, if you see the response which we got is 1-0, which as this is as per the logic which we have. And yeah, so with this I'll be done with my Capstone project. Thank you.